Malaysia is one of the world's biggest palm oil exporters, with around 114 billion in revenue just last year. It is nothing to be made fun of. However, with this big of an industry comes its consequences, and one of them is high carbon emissions. This is emitted from palm and EFBs, and there are many reasons why that this has not been solved. One of them is due to high logistical costs to manage all this waste, and another is the low WTE energy solutions that are efficient and cost-effective to be developed. But we, ladies and gentlemen, here from UTP, our group name called WattWaste might have just the solution, and that's none other than PyPalm.
Hello, I'm Andra and I'm the team leader for WattWaste.
Hi, I'm Muhammad Fahim and I'm the researcher for WattWaste.
Hi, my name is Arish Shami. I'm the video editor and illustrator for WattWaste.
The innovation project that we currently work on is PyPalm, which is a waste-to-energy solution that directly converts palm oil waste into clean energy through the process of pyrolysis. So our PyPalm project is aligned with SDG 7, 9, 12 and 13. PyPalm project is a project that can process the palm oil waste directly at its sources. So it can significantly reduce the transportation cost and also improve its efficiency. Our first main objective is to produce green energy sources and economical viable sources. Our second main objective is to reduce the carbon emission from palm waste.
Let me explain to you how it works. Our machine works by converting solid palm oil waste into usable energy directly at the plantation site. First, solid waste such as EFB is fed into a hopper and augered into the furnace. Inside this furnace, the biomass is heated at a high temperature in the absence of oxygen. This process breaks down the material into syngas, which is mainly made up of hydrogen and carbon monoxide, along with biochar as a solid byproduct. The syngas produced is stored into a gas tank. Most of the syngas stored will be burned in a generator to generate electricity. Excess syngases will be recirculated to be burned and used as fuel to continue the pyrolysis process. Also, the heat generated from the pyrolysis will be brought up to the hopper, so the next batch of EFB will be dried out. After the pyrolysis process is completed, the byproducts such as biochar can be reused as organic fertilizer, creating a closed loop and sustainable system. We are also planning to add up some safety features. Overall, this mechanism allows us to transform palm oil waste into variable energy and resources efficiently, while reducing emission and eliminating the need for costly transportation.
According to research conducted by Hiroshima University in Japan and Universitas Diponegoro in Indonesia, 52% of 1 kg of EFB will turn into syngas, which is a significant amount. The syngas generated can be used to produce electricity and can also be recycled to supply energy for the heating process.
Let's talk about the feasibility and implementation of PyPalm. First things first, for implementation-wise, since Malaysia has a massive palm oil industry, we believe that we can do pilot projects as well as collaborate with companies that have plantations here around Malaysia to help produce a much more sustainable and more developed product through R&D. Other than that, PyPalm also contributes directly towards the National Energy Transition Roadmap. Under the section of bioenergy sources, we believe that PyPalm has to create new bioenergy sources by taking palm oil waste and creating it into clean green energy that can be used to contribute directly towards the national grid. Now let's talk about the benefits of PyPalm. In terms of environmental-wise, since it produces biochar as a byproduct, it acts as a carbon sink, which helps greatly reduce the emissions of carbon dioxide and methane into the atmosphere. In terms of social-wise, PyPalm helps SMEs by helping them follow MSPO standards as well as providing them with a reliable source of energy, especially for the mills in remote areas. And finally, in terms of economically-wise, PyPalm has to reduce costs in terms of energy as well as logistical costs, since the EFB can be processed on site and as well as produce energy for the area. If we look at the current WTE solutions that rival against pyrolysis, the other one is anaerobic digestion. Anaerobic digestion takes a long time, which is around 20 to 30 days. Compared towards our product PyPalm using pyrolysis, it can take a matter of minutes or hours only, since we are burning the waste directly and producing the byproduct. So if we look at anaerobic digestion, it produces biogas, while our product produces syngas. Well, biogas is mainly made out of CO2 and syngas is mainly made out of H2. Therefore, syngas is a much more reliable source of energy that is made out of H2, which is a much more easier compound to burn. In conclusion, our project tackles one of Malaysia's most biggest industries that's producing a lot of carbon emissions into the atmosphere, and we hope that PyPalm can be part of that. We believe PyPalm is one of the ways forward in Malaysia's transition towards clean, green energy, where it can help to take this palm waste that's a lot in Malaysia and turn it into a much more sustainable source of energy that can be used for all Malaysians here in Malaysia.